Hello everyone. We'll continue with electrostatics. In the previous lecture, we have learned the properties of charges and the Coulomb's law. Today we'll also study the principle of superposition. Combining that with Coulomb's law, we'll be able to solve a lot of numericals. So here comes the principle of superposition. To understand this effect, we'll take an example. Suppose there is a positive charge, call it Q1, and there is a negative charge, call it minus Q2. So if I study the force on this positive charge, we know that this positive charge will be attracted towards this negative charge, or this negative charge would be attracting this positive charge. Okay, we are studying the force on this charge only. And let us suppose there is another negative charge which comes into the vicinity. So what will it do? It will start applying force on this positive charge. Let us call this force as force on 1 due to 2. Call this force as force on 1 due to 3. So the principle of superposition says that the net force will be the vector sum of these forces. Net force will be vector sum of these forces. That means you can assume that the force applied by Q3 on Q1 does not in any way affect the force applied by Q2 on Q1. These forces stay independent. That is why we can use this relation that net force is the sum of individual forces. So we can write here net force is the sum of, we should write vector sum of, net force is the vector sum of individual forces. Of course, here the force is due to Coulomb attraction or repulsion. In other way, we can write this. Suppose there is a charge Q1 and there are several charges applying force on it, multiple charges around it, either Q2 or Q3, Q4, take some charges as negative, Q5. So all of these charges will be applying force on Q1. So this will be force on 1 due to 2. Force on 1 due to 3 will be in this direction. And all these quantities are vectors. Force on 1 due to 4 will be in this direction. And force on 1 due to 5 will be in this direction. So we can fairly assume the net force on charge 1 on Q1 is the vector sum of force on 1 due to 2 plus force on 1 due to 3 plus force on 1 due to 4. Likewise, we can extend up to all the forces. This is the principle of superposition. So force between two charges is not affected due to other charges. You can write this statement. Force between two charges will not be affected by other charges. Will not be affected by other charges. So इस नए चार्ज की वजह से इस पुराने वाले फोर्स पे कोई भी इफेक्ट नहीं होता है. नए वाले चार्ज का अपना फोर्स होगा, पुराने वाले चार्ज का अपना फोर्स होगा, and net force will just get added up vectorially. So application of this will be if multiple charges दिए हैं, then we can calculate the amount of force. We'll do some question. Suppose there are two charges, plus Q and plus Q. And There is the charge 4q here. Distance between these two is r. And this is also r. And let us say you want to find force on charge A. Question is, find force on charge A. So to solve this, I'll draw the free body diagram of this. You know that the forces will be in the along the line joining. So due to plus q, the force will be in this direction. This will be force due to small q. Let me name this charge as 1 and name this charge as 2. This will be force due to 1 and 4q will repel it in the other direction. So it will be force 2 that is in the other direction. So net force I can write it as, it will be F2 minus F1 and direction will be in the leftwards. You can write left or you can also write a minus j cap for it. Value of F2, that will be 1 by 4 pi epsilon naught 4q over r square, and here it will be 1 by 4 pi epsilon naught. The charge is q, so there should be 4q into q, and here F1, that is force on charge q due to this charge, that will be just q into q over the r square. If we calculate this, we get the net force as q square by 4 pi epsilon naught r square, and 4 minus 1, that will be 3 times. This is the net force on this charge q, on this charge A. Next question. Suppose you have an arrangement like this. There is a charge A, B, and C. There is arrangement of two charges A and B. They are separated by some distance. Call it R. Magnitude of the charge is, let us say on this, it is plus Q, and on this one, it is plus 4Q. Both are positive charges. Now, what I need you to find is that I want to place a third charge, capital Q, somewhere here. Third charge somewhere here, such that Q remains at rest. The charge C, that is charge on it, this is plus Q. Find the point at which I should keep Q. Find the point at which charge Q, that is charge C, should be kept such that it remains at rest. Such that it remains at rest. So to figure this out, we need to draw the free body diagram. I know that both of them charges will be repelling it. Both of the charges will be repelling it. So plus Q wala force lagayega left direction mein. I can write the force, let me call it as force due to A, and 4Q wala force lagayega right direction, left direction. Plus Q वाला फोर्स लगाएगा राइट डायरेक्शन में, प्लस 4Q वाला फोर्स लगाएगा लेफ्ट डायरेक्शन में. And if the charge wants to stay at rest, then ये वाले charge A and B were fixed. A and B were fixed. Charge A is fixed and charge B is fixed. I want to place Q in such a way that it remains at rest. So let me take assume this distance between these two charges as x. So the force on A should balance the force on B. force on A, that can be written as K Q upon x squared, and force on B, it can be written as K capital Q into 4Q divided by, if this is R x, this total is R, then this will be R minus x. So KQ into 4Q over R minus x squared. I need to solve this equation. Let us see if we can solve this to find the value of x in terms of R. K, Q, and Q will get cancelled out. I'll get 1 over x squared equals to 4 over R minus x squared. That gives R minus x by x equals to whole square equals to 4. So R minus x over x is 2. This will give me x is equal to R by 3. X is equal to R by 3. So I should place this charge R by 3. That is closer to the smaller charge and away from the bigger charge. If this is R by 3, the remaining distance would be 2R by 3. So to keep this plus Q charge at rest, I should keep it R by 3 distance away from charge A. Let's do one more question like this. So two charges are given to me. This has charge 4Q over it, and other particle has charge 9Q over it. And they're fixed, of course. These two charges are fixed. And along the line joining, which is given to me as, let us say 5 centimeters is given, the distance between the charges. And I want to put another negative charge here of magnitude Q, call it minus Q. So the question is, find the position of Q, or minus Q, such that it stays at rest or it stays in equilibrium. So think about this question. You'll find that both of the charges will attract minus Q. Both of them will attract minus Q. So if both of them apply the attractive force, this will be force applied by 9Q charge. And this will be force of attraction by the 4Q charge. And force of attraction by the 4Q charge will be balanced by the force applied by the 9Q charge. So this will come out to be 1 by 4 pi epsilon naught 4Q into Q. I'm not writing the negative sign because I have already shown the direction. Divided by, let me assume this distance to be R, or we can assume this distance to be X. So the remaining would be 5 minus X. Centimeters, of course, because 5 is in centimeters. You can only subtract centimeter from a centimeter unit. So 4Q into Q, the distance is X squared. That is equal to 1 by 4 pi epsilon naught into 9Q into Q. Not writing the negative sign because I have already shown the direction. Divided by 5 minus X squared. A lot of things gets cancelled here. 1 by 4 pi epsilon naught Q and Q, Q and Q. What I get is 4 by X squared. This equals to 9 by 5 minus X squared. Let us see if we can solve this. 5 minus X by X whole square is 9 by 4. So I can write 5 minus x by x equals to 3 by 2. So x would be 10 by 5 centimeter, that is 2 centimeter. I'm getting the value of x as 2 centimeter. So I should put this charge at 2 centimeter away from the 4q charge. So the remaining would be 3 centimeter away from the 9q charge. It is farther away from the bigger charge because force is proportional to the amount of charge and inversely proportional to the distance. So बड़े वाले चार्ज से ज़्यादा दूर रखना पड़ेगा इसे. So this is we can use Coulomb's law as well as principle of superposition to do these types of problems. One more we'll try. Let us say two charges given है. One of them is 9q and one of the charges q minus q. This is positive, this is negative. Then on this line joining, I want to keep a third charge q somewhere. I want to keep a third charge q somewhere. This charge is positive as plus q such that it remains in equilibrium. The distance between them is suppose given as r. So question is, find the position where plus q should be placed such that it stays in equilibrium. So of course, these two charges are fixed, but plus q, you can hold it and move it freely to find out the position at which the charge will experience no force. So see, first thing you can do is figure out at which place should you keep the charge. Means you can try to keep the plus q charge over this side, or you can try to keep this plus q charge over here, or you can try to keep the plus q charge over here. If you keep the charge in the middle, you'll see that force applied by 9q as well as force applied by minus q both are in the leftward direction because negative charge will attract. So this is not possible. If you keep the charge on the left side, then positive charge will be repelling and the negative charge will be attracting. But see, negative charge which has less charge is kept far away from this plus q, while positive charge is closer. So bigger charge, if kept at smaller distance, it will apply a much larger force. So here always the force due to 9q will be greater than force due to minus q, of course in magnitude. So that's why only one option is left. Let me seek this one. Force due to 9q is on the left, force due to minus q is on the right. And larger charge has a greater separation from this plus q. So let us say the distance of this point charge is x. So we'll equate this. Force due to 9q is equal to force due to minus q. So force due to 9q, I can write it as 1 by 4 pi epsilon naught 9q into q. I'll ignore the value of negative charge because force का direction already taken है. So distance from 9q will be this r plus x whole square divided by 1 by 4 pi epsilon naught into small charges q and distance is only x. Let us solve this one. Some things get directly cancelled out. What I get here is 9 equals to r plus x by x whole square. From here, I get 3 equals to r plus x by x. So x will be equal to r by 2. X is coming as r by 2. So I should place this negative charge at r by 2 distance from the, place this plus q charge at r by 2 distance away from the minus q charge, such that it stays in equilibrium. This is again another example of principle of superposition. Let us take some more numericals. This question is, find net force on charge A. First question is like this. I have an equilateral triangle. There are 3 charges over it, each of magnitude plus q. And this is the charge A on which I want to find the force. So see, it's also the distance between the charges is given as A. If you want to find force on charge A, you will apply principle of superposition and then Coulomb's law. So charge due to this plus q on this plus q, it will be k, I'll call it f, that will be k q square upon a square. Then force due to this charge on this charge will be along the line joining and away. The value will remain the same, that is k q square upon a square. This is an equilateral triangle, so this angle is 60 degree. This is also 60 degree. So you can calculate it using vector, that net force will be, you can use this formula, root over a square plus b square plus 2ab cos theta. That is the resultant of 2 vectors. If 2 vectors are given, the resultant is given by this formula, that is a square plus b square plus 2ab cos theta whole root. That is the sum of 2 vectors, and the angle of resultant with the a vector is given by b sine theta upon a plus b cos theta. Either you can use this formula or you can use a shorter trick to find the resultant here. Another way to would be to use a component of vectors. If you use this formula, what you'll get here is the net force is f root 3. And alpha value will come as 30 degree. So the value of net force will be along this direction. Value will be f root 3. Value of f you can put later, that is kq square by a square, and it is 30 degree below the vertical. 30 degree below the vertical. Another method that you can use here is like this. Instead of finding the resultant using the formula, I can take component along 2 directions. So this is 60, so half will be 30. This will be 30. So I can take component along this direction. This will be f cos 30. And component of this along this will be f sine 30. Again, you can take component of this f on this. It will be again f cos 30. As this is a right angle triangle, this is a right angle. Again, you can take component of f over here. It will be f sine 30. So like this, you can take component of vectors and f sine 30 gets cancelled out. You'll get 2f cos 30. If you have doubts in vectors or mathematical tools as such, you can refer to my mathematical tools lecture. Suppose, again, there are 3 charges on an equilateral triangle of side A. This is minus q. This is plus q. This is plus q. And you have to find net force on this charge. Next question. Let us say 2 equilateral triangles are joined together, one over each other, like this. All the sides are A. Charges here is minus q. Here it is minus q. Here it is 2q. This is your charge A. Magnitude of charge on this is q. Now, next question is like this. 4 charges. Charge on this is minus q. Here it is plus q, plus q. This charge is A, and charge over this is plus q. Also, this is a square of side A. So all the angles will be 90 degrees. To find force on this charge, charge A. This will be the question that you have to solve. Let me first solve this one. So negative charge will attract it. So I'll get a force in this direction. Then positive charge will repel it. I'll get a force in this direction. FF, this is 60. So this will be 120 degree. 120 degree. And if I want to take the component, I will take the component in the middle direction. So if total is 160, then half would be 120. Total is 120, so half would be 60 degree. So I can take the components like this. It will be f cos 60, f cos 60. So here it is 2f cos 60 degree. And the f sine 60 part, it gets cancelled out. Along this direction, it will be f sine 60. I'm taking the component of this force over this and over this. F sine 60 gets cancelled out. The resultant force is 2f cos 60. That will be just f. What is f? F is simply written as kq square upon a square. That is f. Next, suppose you want to find the solution for this. So here the force will be repulsive on this. 2q, force is 2q. To calculate it will be f. What is f? F is kq square by a square. Negative. So it will be f here, f here. This angle is 120. So half would be 60 degree. This is 60 degree. This is also 60 degree. I can take components of f in two direction. So f cos 60 here and f sin 60 over here. Again, I'll take the component of this f, that will be f sin 60 over here, and f cos 60 will get added, so 2f cos 60. So this will be 2f cos 60, that is f, and this is 2f. So resultant will be 2f minus the f. So net force is just f, that is kq square upon a square towards the right direction. If you want to solve this, so force on this A due to this charge will be F here, and due to Q it will be F here in this direction. And if you calculate the resultant of F and F, you'll get F root 2. That is a resultant of these two, because it is F cos 45, F cos 45. So that is 2F cos 45. But this negative charge will be attracting it. This force due to negative Q, if you want to solve it, that will be K Q square. I'll ignore the sign because I'm taking the direction, and distance will be root 2a. So this will be F by 2. So F due to minus Q is F by 2. So you can write the net force is F by root 2 here and F by 2 here. So the net force will be written as, in this direction, F net will be F root 2 minus F by 2. If I take the F common, it will be root 2 minus 1 by 2. That I can write it as the net force is equal to kq square upon a square root 2 minus 1 by